All right, welcome to this next session of Refuting the Critics. In this specific video, I will be teaching Forrest Valkai, a proponent of common descent, exactly why evolution is false and biblical creation is true. And I want to get right into the video that we are going to be responding from Forrest Valkai here. Now, as you know, here on Standing for Truth, we like to leave no stone unturned. We engage all challenges and interact with our critics. And we have countered many objections and challenges offered by your most militant guardians of common descent. I have had many people reach out, whether it's through email, Facebook, or in comments, to respond and refute Forrest Valkai. And so I've compiled a few videos. One thing that I noticed from him is a lack of engagement on our very best arguments and points from the biblical creation perspective. And I did find one specific video. It's in the form of a short where he attempts to engage the incredible scientific evidence that has confirmed Adam and Eve and has confirmed exactly what the Bible, specifically in the book of Genesis, offers us in terms of the origins of humanity. And so I will start with that one. And then I've got at least one other video that I will be responding to him on in a future session. And so with that, let's get right into what Forrest Valkai has to say on Adam and Eve. Here we go.
So I am currently deep in the heart of Texas, but I want to take a second to answer this question. It's a really good question. The term mitochondrial Eve refers to the fact that we all get our mitochondria from our mothers. Sperm cells do have mitochondria, but they're only in the tails. And when the sperm and the egg fuse, the tail falls off. And so at the end of the day, all the mitochondria in your body came from your mother's egg cell.
I will say this real quickly before he continues. When conventional scientists, when they discovered the reality that all people today, all mitochondrial DNA, which is maternally inherited, so all mitochondrial DNA worldwide can be traced to a single female ancestor in the not so distant past, they coined that more so tongue in cheek mitochondrial Eve. And the same thing with Adam when they discovered that all male Y chromosomes on the planet, Y chromosome is also uniparentally inherited DNA. It's passed down on one side paternally from the father. Okay, so my sons have my Y chromosome. I have my dad's Y chromosome. Women don't have Y chromosomes. Men, we do have mitochondrial DNA, which is outside of the nucleus, but it's not passed on. So when secular scientists coined the terms mitochondrial Eve and Y chromosome Adam, which is more specifically or accurately Y chromosome Noah, we'll get into that. They coined it Y chromosome Adam. This was more so tongue in cheek. But as we're going to see, and as we have seen in our many videos out on this topic, published on this topic, the evidence is not in favor of the evolutionary position. Okay, so right off the bat, I want to point that out, that we do have evidence that all mitochondrial DNA, all Y chromosomes go back to two single ancestors, one male and one female. They coined those ancestors mitochondrial Eve, Y chromosome Adam, tongue in cheek. Okay, but as we're going to see, this data fits beautifully with what we would expect from a biblical creation starting point.
Now, similarly, there is a Y chromosomal Adam because Y chromosomes can only exist in sperm cells because why would an egg cell ever have one? So this kind of perpetuates this idea that we came from two people, a Y chromosomal Adam and a mitochondrial Eve, but no, that's not accurate at all. In fact, genetic analysis shows those two people would have lived.
Now, he's only making assertions, but I will give him the benefit of the doubt because as someone who puts out shorts, you got to get your material, you got to get the information in there in a short amount of time. And so, yeah, he's not backing anything up here. He's making assertions. But if he had a longer video on the topic, I would love it. If somebody had a longer video where he attempts to refute the scientific evidence for literal Adam and Eve right from the Bible, then please send me that. Or we'll see how critics respond to this one.
About 100,000 years apart. So no, it just doesn't make any sense. And this is why scientists should really stop using things like poetry and mythology to try to make things make sense, because while it is very pretty, it just ends up causing more confusion.
I would say this is why critics like Forrest here need to spend more time interacting with our best arguments. And he should make sure to stay as up to date as possible in terms of what we in the world of creation are saying, because it, as we're going to see, is very easy to demonstrate the reality of an Adam and Eve that existed just a few thousand years ago. Let's get into the data on this topic. And so, firstly, the observed rate, what we observe empirically, okay, in terms of mutation rates, whether we're looking at the mitochondrial DNA, whether we are looking at the Y chromosome, the mutation rates are fast, okay, and there's low diversity. Therefore, it's easy to get a Y chromosome Noah and a mitochondrial Eve in biblical time. 4,500 years since the flood, roughly 6,000 years since creation. Now, the Bible makes some very specific claims on some very specific genetic related claims. Okay. Notice here, the book of Genesis makes several genetic statements with significant implications. And quickly going through those, here's a couple. Genesis 2:7, the Lord God formed man out of the dust of the ground. Eve, and the rib which the Lord God had taken from man, made he a woman. And so we see no hint at common ancestry with the great apes. We see no hint of common descent. And we have Jesus Christ himself saying from the beginning of creation, specifically here, Matthew 19:4, and he answered and said unto them, have ye not read that he which made them at the beginning made them male and female, referring to the creation week and day 6, where Adam and Eve were first created. And from the beginning of the creation, God made them male and female. Adam, the first man, and then Genesis 3:20, Eve, the mother of all living. I'm going through this quickly for a reason. It is because I have given a 90-minute talk on the best scientific evidence for Adam and Eve that I will make sure is linked in the description box of this video. And I go over all the scriptural and scientific evidence in detail. I also, with Matt, we did a 3.5-hour program on this topic with Brian from Apologetics 101. So for a comprehensive breakdown on all the important details, do check that out. And so let's just get into a few reasons why Forrest Valkai needs to update himself on the science of Adam, Eve, origins, and ancestry. Now, Forrest, he put out a video, if I remember correctly, it's titled How to Teach a Creationist Evolution. And it is going to be a lot of fun. I'm really excited to respond to, especially his claims on mutations. He goes into the definition of evolution, and it is going to be a real treat to respond to. So stay tuned for that. Now, the Bible claims to be the history book of the universe. What do we see? We see one woman, one man, Eve and Adam. Okay. We see Jesus calls them the first two people. From the beginning of creation, he made them male and female. They are created separate and special. Okay. independent from any other form of life. That includes the great apes like chimpanzees, bonobos, gorillas, orangutans, and that, of course, includes strawberries and pine trees. That is the separate ancestry model. The humans are created separate, independent, and special. Independent, that is, from any other form of life. And so the Bible, again, claims to be the history book of the universe. There are some very specific statements there that we can compare to the empirical scientific data. And we can make very specific predictions. Adam and Eve predictions. We would predict, well, we already know that this exists, as Forrest pointed out, but he says that the numbers are inconsistent with the biblical timeline. And we are going to see that that is not the case. When I say observed rate, a pedigree, for example, in terms of mitochondrial DNA, take grandmother, mother, daughter, count up the differences. What you get is a fast mutation rate. In the mitochondrial DNA, it's anywhere, depending on what study you look at, it's anywhere between 0.1 per generation, as high as 0.5. Okay. And the mitochondrial genome is only about 16,500 letters. So it's a smaller chromosome. The Y chromosome is about 65 million or so letters. And the mutation rate in the Y chromosome, so say you take grandfathers, fathers, sons, count up the differences, okay, you get a fast rate, somewhere between 1 and 3, especially if you use high sequencing data. And so that's biblical time right there. Few DNA differences in both compartments, fast mutation rate. The critics, the PhDs out there, they do have rebuttals, and we'll get into some of that. So here's some predictions. Low diversity, 1 Y chromosome ancestor, 1 mitochondrial DNA ancestor. Turns out these biblical creationist expectations, Forrest, have been confirmed, and they need to be addressed. Quickly, why low genetic diversity? Well, the reason why we would predict low genetic diversity is simply because if God created just 2 people 6,000 years ago, what does that do? That restricts levels of genetic diversity. That's 2 people. You're obviously going to have limited genes floating around. Okay. But if the evolutionary model of human origins were true, then we would expect higher levels of genetic diversity, higher than what we see. And I'll tell you why. It's because according to the evolutionary model, we've been evolving for millions of years from Australopithecine-like ancestors up to Homo habilis, into Homo erectus, who apparently lives on the globe for 1 million plus years. And then eventually you have Homo sapiens, Homo sapiens sapiens. As a matter of fact, they have 2 out of Africa's. First out of Africa, Homo erectus leaves Africa. Some say he, erectus, a hominin, pre-human hominin, according to them, evolves independently into different hominin groups. Okay. Like Heidelbergensis, Floresiensis on the island of Flores. Some might even say Homo naledi, Neanderthal. And then in Africa, you have that lineage of erectus that did not leave. They evolved into Homo sapiens, humans. And then humans leave Africa eventually, and they meet up with these other groups, which was a surprise to the paleoanthropological community that we have other groups that we apparently intermingled and interbred with. We mated with them. We have their genes. There is gene flow. Neanderthals, Denisovans, for example. Okay, we have their genetics. And so we would expect a lot more diversity. Mutations add diversity because they're adding something that was not previously there. And therefore, if you're accumulating these mutations every generation from pre-human hominin ancestors to humans, or you want to just consider the bottleneck, roughly 100 to 200,000 years ago, according to their model, in Africa, you'd expect a lot of genes floating around these populations. And this also goes for Y chromosome and mitochondrial DNA, because if you have these people groups independently inside Africa, outside Africa, okay, across Eurasia, in some cases with so-called hominins like Neanderthals, they're accumulating their own DNA differences, their own unique genetic markers independently from humans in Africa. Like Neanderthals, Denisovans, Heidelbergensis, Erectus. So we wouldn't actually expect to find a single Y chromosomal ancestor and a single mitochondrial DNA ancestor. We'd expect to find many. Okay, we'd expect to find a lot more diversity in these DNA compartments. But what we find is low genetic diversity. So here's an example. You have a lot of time, according to the evolutionary model, to accumulate DNA diversity. So the separate ancestry model predicts low diversity. The evolutionary model predicts higher levels of genetic diversity. What do we find? Every single human being is nearly identical genetically. Low diversity in mitochondrial DNA, low diversity in the Y chromosome, low diversity overall, autosomal nuclear DNA. Okay. Notice this. Human genetic diversity is substantially lower than that of many other species. Any two human beings are 99.9% identical. All human beings are 99% identical in their genetic makeup. This is fascinating. And the evolutionary community did not predict this. The rescue devices don't work. Okay, again, if God created just two people 6,000 years ago, that would restrict levels of genetic diversity. Now, what the evolutionary community invokes is a massive population bottleneck in Africa in the distant past. So apparently you have a population crash. The population is now at somewhere between 2,000, 10,000, some say 30,000. But this is not just a one generation bottleneck or a two generation bottleneck. This is an extended population bottleneck, and it has to be in order to reduce the necessary levels of heterozygosity, which is just more DNA diversity, and increase the levels of homozygosity, which is less genetic diversity. But the problem is, this would be a near extinction event. And what happens in these events is inbreeding, severe inbreeding, because this population stays small, stays isolated for an extended period of time. Inbreeding reveals the hidden reservoir of genetic mistakes. These deleterious mutations that have been accumulating over time, those that are in recessive form, they come to the forefront. They lead to rapid and accelerated genetic degeneration. They leave populations genetically compromised. These would be coming to the forefront, leading to disease, leading to degeneration. And we're supposed to believe that this genetically compromised, highly diseased, hypothetical population of human beings in Africa suddenly explodes in all parts of the globe, seizes dominion over the planet, invents automobiles, airplanes, computers, and basically the sophisticated world that we live in. No, this is something they can believe in, okay? But it is not science. It's evolutionary philosophy. And again, you would expect to find more mitochondrial DNA lineages, more Y chromosome lineages. You wouldn't expect to find just a single Y chromosome lineage and a single mitochondrial DNA lineage. Okay, evolution, it didn't have to be this way if evolution is true. But for biblical creation to be true, this is what the model demands. One woman, one man. And it just so turns out, coincidentally, according to the skeptics and the critics, that this is exactly what we find. This is exactly what the data suggests. It confirms the biblical creation model of ancestry. Okay. One thing that coalescence, for example, one assumption of it is random mating. And they'll say, based on coalescence and statistics, you're bound to go back to a single woman and a single man. Here's the problem, though. Historically, random mating isn't true. In the evolutionary model, you have people in tribes separated from each other. And so typically, you have people marrying within their groups, marrying within their tribes. You're not going to have random mating from a group in Australia and a group in Africa. Or if you're in Africa and you have these different tribes. So you have the population, let's say 10,000 or 30,000, but it's broken up into different groups and different tribes. You're not going to have random mating. And you're certainly not going to have random mating during that time frame where you have humans in Africa. Outside of Africa, you have groups like Heidelbergensis, Neanderthalensis, Erectus. Okay. You certainly don't have random mating there. So we should be expecting a lot of unique genetic markers, a lot of different lineages, a lot more diversity. What we see in terms of the Y chromosome, the mitochondrial DNA, and the genome as a whole is not really what we'd expect if the evolutionary story of human origins were true. Okay. So you don't have random mating historically. And so we should find many different mitochondrial DNA lineages and many different Y chromosome lineages. But we don't find that, do we? No, we don't. We find one single mitochondrial DNA lineage and one single Y chromosome lineage. And that Y chromosome, when you consider overall architecture, gene content, and size differences, bring in with the evolutionary community, somebody like Forrest Valkai would argue, bring in the chimpanzee, who's our supposed closest cousin. They'll say humans and chimpanzees share a common ancestor, and their most recent common ancestor goes back about 6 to 9 million years. Well, it turns out, and I've done whole presentations, I've written articles on this, I've discussed it in my books. The Y chromosomes of humans and chimpanzees are less than 30% the same. 30% the same. Okay, those are some massive differences that the evolutionary community, guardians of common descent, need to account for. And they're having a real difficult time accounting for it without stories, imaginative storytelling is what we're seeing in terms of that. So that works great. Every single male Y chromosome on the planet, nearly identical. It could be traced back to a single Y chromosomal ancestor in the not so distant past. And then when you bring in chimpanzee Y chromosomes, they're nothing alike. Then you bring in gorillas, and it turns out there's an inconsistency with the expected nested hierarchical pattern of common descent, where the human Y and the gorilla Y are more similar to each other than either are to the chimpanzee Y. Well, that's interesting because apparently humans and chimps are supposed to share a more recent common ancestor. The real Eve. Okay. Mitochondrial DNA, I explained earlier, it's uniparentally inherited. It's passed down on one side. That's the mother's side. It exists outside of the nucleus in an organelle called the mitochondria. You've heard it many, many times. That would be the cell's power plant. And this is highly functional, very important DNA. It controls the conversion of sugars into energy. Okay. In each cell, you have many little mitochondria that are working to produce energy, to help us live, to breathe. It essentially produces energy to sustain life and bodily function. So very important. Now we can take mitochondrial DNA, okay, and we can, I presented on this many times, we can compare it worldwide. It's only roughly 16,500, specifically here, 16,569 letters. You can line them up, compare them, and you're going to see that there's very low variation in the mitochondrial genome. This is a paper directly from the conventional literature by Dr. Rob Carter. The world consensus sequence is unambiguous except for a very few nucleotide positions. Okay, so low variation, only a few. I mean, on average, somewhere between 25 and 30, let's say, DNA differences separating any two people in the mitochondrial DNA. Max, you're looking at some of the African lineages, 120, maybe 140. And so even the max is quite low. Okay. And so what you would expect if the Bible's account of origins were true and biblical Eve was true, the mother of all living, we'd expect low variation. What we see is, again, a match to biblical expectations. Okay. And so how this was done, basically to get a consensus sequence, they've got updated data now, but the reality or truth behind it still stands. And so you can look at the letters. You're going to see that 85% of them are basically the same, where everybody on the planet has the exact same letter. So if everybody on the planet has the exact same letter, that means Eve would have had that letter, right? So let's say everybody in the world has an A, but then you have a couple of people that have a T at a specific location. But what did Eve have? Eve would have had the A. Okay. And so if you look here at this visual, these are counts of sequences, and people differ by only a few, roughly 22. Updated data might say a little bit more, 25, 30. Okay. And therefore, if you compare all people today on the planet to Eve, most people are just a few differences away from Eve. So we're not really concerned with species-wide change. We're concerned with how long does it take to accumulate these few differences from a roughly created sequence, from Eve's sequence. It doesn't take much time at all to accumulate these differences. On average, 25 to 30 with a max of about 120 to 140. How long does it take to diverge from Eve? And if you're comparing all people today on the planet to Eve, they're just a few differences away from Eve. And then in a small fraction of the letters, you'll see variation, since 85% of the mitochondrial genome is identical. But if the genome is very old, you'd actually expect the graphs here in a way to be opposite, where you'd find many more mutated sequences. Okay, but we don't find that. Now, the argument being, so for example, here's a phylogenetic tree. Okay, we'll put it full screen. Forrest Valkai, if he's going to make these assertions, he's going to have to debunk this data. This is mitochondrial DNA worldwide. Okay, it's actually reflective of explosive growth, rapid and exponential growth, which is what we'd expect from the Bible. That's where you see that starburst pattern. Okay, now you'll also find, very interestingly, you'll find variation in mutations, irregular mutation rate patterns. For example, take the HVR haplogroup. This is the most common in Europe. You'll notice differing size branches. Well, the branches reflect DNA differences or mutations. So these are mutations in people groups over time. Okay. It suggests one woman, rapid and exponential population growth. That's exactly what the Bible would describe, right? The Bible describes a bottleneck at creation, Adam and Eve. Adam and Eve start having kids, their kids start having kids, so on and so forth. Then you have a bottleneck, massive bottleneck, couple thousand years later at the time of the flood. And then you have Noah, his wife, their three sons, Shem, Ham, and Japheth, and their three wives. It also turns out that your three major haplogroups, L, M, and N, correspond nicely with what the Bible describes as the earth being overspread by these three reproducing couples. Noah's three sons and their three wives, so his three daughters-in-law. Okay, and so what we see is a pattern that fits. In the HVR haplogroup, again, most common in Europe, you find differing size branches. What does this mean? This means that some people are picking up more mutations in the same amount of time than their cousins, because they all go back to a common ancestor. And so this breaks in many ways the assumptions behind the evolutionary molecular clock, because now you can't assume a constant rate or a constant clock. If some people groups are picking up more mutations in the same amount of time, just because you have a longer branch or a people group, let's say like Neanderthals with more mutations, that doesn't mean they're older. There's other factors at play. And so now we see evolutionary scientists like Dr. Dan Stern-Cardinal, they point out the nature of the mitochondrial chromosome. Again, what does that DNA do? It is very important functionally. It controls the conversion of sugars in energy. Basically, it creates ATP. So if it's going to get hit with deleterious mutations, then selection will act a lot better on the mitochondrial genome than it would on, let's say, autosomal nuclear DNA. There's a lot more that can go wrong in your autosomal nuclear DNA. Remember, you inherit 3 billion from mom, 3 billion from dad, because we're diploid. But haploid genomes, for example, the mitochondrial genome is haploid, which is why it largely accumulates mutations in a hatchet-like manner, a ratchet-like manner. And so the problem for the evolutionists is, and that they are desperate to counter, is the fact that well-known evolutionary scientists like Fatuma, I wrote a technical article with Chris Roop on this. It was peer-reviewed by Dr. John Sanford, and it's been tested, and it still holds true today. So notice this in an introductory level textbook, Evolution, Douglas Fatuma. Since on average it will take 4 NE generations for such mutations to reach fixation, about the same number of neutral mutations should be fixed every generation. The rate of fixation of mutations is theoretically constant. And what's this? Equals the neutral mutation rate. So these critics, I want to say, well, the per generation rate, yeah, that's fast, but selection removes most mutations over time. And therefore, what we need to be looking at is your phylogenetic or your fixation rate, the rate as to which mutations accumulate in the actual species over time. Fixation, they become stuck in place. Okay, the species-wide change. The problem is basic population genetics tells us that the neutral mutation rate, including effectively neutral mutations, equals or approximates the fixation rate. Okay, this is basic population genetics. Now, someone like Dr. Dan Stern-Cardinal, and I appreciate the engagement from proponents of evolution on this very technical issue, okay, is they'll say, and they'll look at papers that talk about the ratio of synonymous and non-synonymous mutations. I did a response video recently where I discussed for an hour and a half Neanderthals, this issue, and also unconstrained sequences and nested hierarchical patterns in unconstrained sequences. So I'd recommend people check that out for all the important details on this. But in a nutshell, a real quick rebuttal, when you look at the ratio of synonymous and non-synonymous mutations, it does look like that there's parts of the mitochondrial genome, about 50% it looks like, that has no mutations. So either there's a lot of cold spots where they're simply not getting hit with mutations, or selection is acting where there were mutations there, but selection is removing them because they're deleterious. The reason why everything balances out for the most part in both autosomal nuclear DNA and mitochondrial DNA, and will include the Y chromosome that is nuclear DNA, but it is uniparentally inherited. Okay. And so things largely balance out because when you have small populations that are isolated, they're not spreading out. You notice here, is fixation faster in small isolated populations? Yes. Fixation, the process by which an allele reaches a frequency of 100% in a population, occurs faster in small isolated populations due to the increased influence of random genetic drift. Smaller populations achieve fixation faster. So here is the problem, and the important point that many in the evolutionary community and camp don't recognize or forget is, according to both models, you have periods of time, both the evolution and creation model, you have periods of time where fixation is very fast. Okay, today you have what, 7 to 8 billion people on the planet. So fixation is basically zero. If you have a random farmer somewhere in America who gets hit with a unique mutation, that's not going to spread to all people on the planet. Okay. But in the past, let's take evolutionary history, for example, the last 6,000 years of history is like the tip of this pen. It's nothing. It's an extremely short amount of time. Okay. So they want to go back 100 to 200,000 years ago into Africa. Okay. And they have humans existing in small tribes, isolated. You have population surges, population crashes. Okay. And so you have fast rates of fixation for most of evolutionary history in terms of the evolutionary history of humans. In the creation model, right after the flood, we have a massive bottleneck where now we only have 3 reproducing couples, but people don't actually spread out in all parts of the planet until the languages are confused and they're forced to do so at Babel. So let's say Babel was 100, maybe 300 years after the flood. Okay, numbers differ in the creationist literature, but nonetheless, you have from that initially very small population rapid rates of fixation, especially if mutations are coming about rapidly right after the flood, the negative conditions associated with the flood. Okay, environment can affect mutation rates. And so until people, let's say somewhere between 100 and 300 years after the flood, you have rapid rates of fixation. Okay. And then people are forced to spread out into all parts of the globe, and then fixation becomes slower. Well, there's a balancing out effect. Just like in the evolutionary model, you have an extended period of time according to their model, but you never have people reduced to just 8 for a time. Okay. You have fixation being fast, very fast. Creation model, faster rates of fixation. Okay, so even in the mitochondrial genome, even if you have purifying selection, things will largely balance out to where you have the mutation rate approximating, not being exact. They're going to diverge a bit, but certainly not enough to get the mitochondrial DNA compartment going back 100 to 200,000 years ago. No, the diversity is too low. The mutation rate's too fast. That also goes for the Y chromosome. This is a Y chromosome phylogenetic tree. Mutation rate is fast. We see evidence of one man, all male Y chromosomes go back to a single man. Diversity is low. Mutation rate is fast. We see evidence of rapid and exponential population growth. This is exactly what we would expect if the Bible's account of origins were true. And so, again, yes, you can have selection on the genome, but things will still largely balance out, because if you're going to look specifically at the evolutionary model, for most of their history, you have faster rates of fixation anyways, because the point in time where we have billions of people on the planet that are spread out, this is a very unique period in evolutionary history. And according to the biblical model, you have this period of time right after the flood where rates of fixation are just incredibly fast. Mutations are accumulating. Lots of interesting things are going on during that time period. And so from those points, considering those factors, everything else is explained. And this is really fascinating data. Here's what I was saying earlier on the human Y chromosome and the great ape Y chromosome, specifically the chimpanzee. You'll notice the human Y chromosome and your chimpanzee Y chromosome. Let's see Forrest Valkai offer a sophisticated response to this data that powerfully confirms the separate ancestry model and overwhelmingly contradicts common descent. And so your human Y, this is heterochromatin here, densely packed pieces of DNA, largely comprising repetitive sequences like satellite DNA. The chimpanzee has lost the entirety of its heterochromatic arm. Where is it? Gene content's different, size is different. It's half the size. The human Y and the chimpanzee Y, they're half the size. Huge differences. And you can see your gorilla, when compared, are more similar than to the chimpanzee. This is from a paper in 2020. Their Y chromosomes differ enormously in size and gene content. It's not just a little bit, it's enormous. The chimpanzee Y is only half the size of the human Y. Show me when, how, where did all this happen? And the percentage of gene families, excuse me, shared by these two chromosomes that split 6 million years ago is similar to that shared by human and chicken autosomes that split 310 million years ago. Puzzlingly, so again, these are the types of data points that have not been predicted. These were not expected. It's not like they had on paper. Like when we get the data, when we get the genetic sequencing data for humans and chimpanzees, their Y chromosomes are just going to be drastically different. Where did they predict one Y chromosome lineage? Where did they predict low genetic diversity? Where did they predict one mitochondrial DNA lineage, Forrest Valkai? It's all post hoc, ad hoc, rescue devices. We get the data, they're puzzled, they come up with a rescue device. This happens over and over and over again. And yet these data points, these points of evidence that the evolutionary community, guardians of fish to fisherman evolution, they are invoking rescue devices to explain away data that the biblical model of ancestry expects and has predicted. We don't have to invoke any fanciful storytelling or imaginative stories. No, we can accept the data for what it is. We can accept the data for what it says. One mitochondrial DNA lineage, one Y chromosome DNA lineage, low diversity, fast mutation rate. And when you bring in the chimpanzee Y, our supposed closest cousin, it's nothing like the human Y. This data is truly fascinating, guys. This is why I say it's a great time to be a biblical creationist. So when Forrest Valkai in his short here asserts that no, mitochondrial Eve and Y chromosome Adam, or specifically Noah, don't go back 6,000 years. This is not the biblical Adam and Eve. He's wrong. He's simply wrong. The scientific evidence, the real-time data contradicts his assertions. And when you bring in this argument that, well, you got to use the fixation rate over the observed mutation rate, it doesn't work. Okay. This is why genetic entropy is an even bigger problem for the evolutionary community, because we know that the mutation rate in autosomal nuclear DNA is high. It's roughly 100 new mutations per person per generation, most of them being nearly neutral, invisible to selection, slightly deleterious, like rust on a car. It builds up largely unnoticed. But what does it do over time? It destroys the car. And the buildup of these nearly neutral mutations over time drive species into genomic sickness. Okay. And what we now know about the mutation rate, the limitations of selection, but also fixation equilibrium, where you have the mutation rate approximating the fixation rate. Every time you have a slightly deleterious mutation that's fixed, that's stuck in place, that is species-wide, irreversible, irreparable damage. And so that is a major problem for the evolutionists. And again, even if you invoke selection, or even a lot of selection in the mitochondrial genome, it doesn't matter, because there's a balancing out effect, since both models have periods of time where fixation is very fast. Notice this on the Y chromosome. The differences between human and chimpanzee Y chromosomes are said to be due to a combination of gene loss, gene gain, and large-scale chromosomal rearrangements. They assume both species are related biologically, go back to a common ancestor. They look at the differences between both species, let's say humans and chimpanzees, and they say, well, this was lost over here, this was gained over here, there was a large-scale chromosomal rearrangement over in this place. It's like a recipe. They're trying to explain all the differences rather than asking the obvious question, are these species related through common ancestry in the first place? Notice this. More than 30% of the chimpanzee Y chromosome fails to align to the human Y chromosome. The portions of the Y chromosomes are said to have been rearranged. The chimpanzee Y chromosome has twice as many large palindrome sequences. Those are sequences within the Y chromosome that serve to protect important genes in male fertility, as the human Y. According to evolutionary scientists, mating habits in chimpanzees are one of the major factors in accounting for the massive differences in Y chromosomes. And so these are major problems. I've gone into the details, possible rebuttals in a couple videos at least. And so I would just recommend people check those out if they want all of the information on this topic. But before I wrap it up here, I did want to showcase one more phylogenetic tree right here. This is backing up what I was showing earlier. I've also released a response in article form to possible objections to this. So arguments that Forrest Valkai could use or repeat from other critics, I can assure you they've been addressed. So this is mitochondrial DNA worldwide. We have the three major haplogroups right here, L, M, and N. They're separated by short lines, which means fewer mutations. The lines radiating out from them are longer. The branches are much longer, suggesting more mutations. This matches exactly what the Bible describes in terms of human origins, where we have Noah's three daughters-in-law, right? L, M, and N, three major haplogroups. They're separated by just a few mutations. And then the lines radiating out, this would represent post-flood history. Pre-flood history connecting the nodes, pre-flood, post-flood, radiating out. So guys, this is the kind of genetic data that critics like Forrest Valkai need to engage. Okay? Because if they're just going to make assertions or they're going to argue against biblical creation in a way that ignores our best evidence or our best models, well, then they're not really putting in the required amount of work to demonstrate that evolution is a superior model in terms of explaining origins. Okay. This is how we're going to advance in this debate, is by engaging each other's best points. And that's why I spend a lot of time engaging what? Endogenous retroviruses, pseudogenes, nested hierarchical patterns, mutation rates, because I want to see what the best the evolutionary community has to offer. And then I want to engage those points. One major point they like to focus on is Neanderthals is one. I've dismantled that in a couple recent videos, but the African branches. So they'll say, well, since Africa has the most diversity and everything nests within Africa. Okay, let's look at the mitochondrial DNA tree specifically. You can see that the longer branches. Well, then Africans must be older than non-Africans. And to them, that refutes the out of Babel model. To them, that says humanity, the origins of humanity go back much further than 6,000 years. But what they don't realize is that everything is going to nest within the epicenter from which we all originated or dispersed from. And it turns out that the epicenter of genetic diversity is right around the Middle East and Africa. Now, where we actually place it, closer to the Middle East or in the Middle East or in Africa, is going to be based on many different assumptions. So whichever one you pick, everything is going to nest within it. The nesting argument doesn't help the evolutionist, okay? And so when we consider things like faster mutation rates, okay, or selective sweeps, right? Let's say you had a selective sweep across Eurasia that resulted in older lineages basically being wiped out, with older lineages in Africa remaining or surviving. Or in Africa, after Babel, you have a higher initial population size where you have waves and waves of people coming from Babel, coming from the Middle East into Africa, right? So many of Noah's family's descendants could have moved into Africa. And what are they bringing with them? A lot of genetic diversity. And so Africa is going to start with a lot of DNA diversity. Neanderthal branches and lineages as well. Many different good explanations for that. Radiation rocks. Neanderthals would have lived in less than ideal conditions. We know they lived in caves, and that would have been the perfect recipe for hypermutation. Right after the flood, you'd have, because of the flood, a lot of heat, energy, and radiation. And so these in harsh environmental conditions, radiation rocks, being exposed to certain chemicals and radiation within cave environments, this would result in reduced selection pressure, altered DNA repair enzymes. And so, no, this doesn't mean that Neanderthals are older. It just means they've accumulated a lot more mutations in a short amount of time. So, guys, we're going to wrap it up there, as I did want to keep this at about an hour. And it looks like that's what we're at. So that was an easy debunking. It was just a short video that he put out, comprising mostly assertions. Again, it's a short. I know that you can't be incredibly comprehensive in a short. Maybe I just didn't investigate or look enough. But when I typed in Forrest Valkai and I tried to look for some detailed videos addressing our points on mitochondrial Eve, Y-chromosome Noah, I didn't really find anything. So that tells me that Forrest is not doing a good job at engaging our best possible arguments. So he might have to go back to the drawing board, or he might actually have to put in the work to address the best that we have to offer. And so in the next video, I will be responding to portions of a video that he has titled How to Teach Evolution to a Creationist. And I'm excited for that. Okay, guys, I hope this video was a help to you. I pray that it was edifying, and that you can see clearly why it is truly an incredible time to be a biblical creationist. God bless all.